Welcome. My name is Mr. David from Arizona High School. Today I'm going to take you through a chemistry lesson on chapter 3 of the book, Atomic Structure. And I hope you are going to get more knowledge out of this. Welcome. Okay, chapter 3 of the book talks about atomic structure. This is one of the most important chapters in the chemistry book because it deals with atoms that makes the major component of chemistry or of chemicals that we talk about in chemistry. So in this chapter, number 1, we are going to define atoms and molecules. So first, what is an atom? We say an atom is the smallest particle of an element. An atom is the smallest particle of an element that can take part in a chemical reaction. We all know what an element is. An element is a pure substance that is made of only one type of an atom. Then what is a molecule? A molecule is made of atoms. The molecule can consist of either one atom or a combination of two or more atoms. So a molecule is made up of atoms chemically bonded together. A molecule is made up of atoms chemically bonded together. The bonding that we use is covalent bond. So we say a molecule can either be made of one type of atom or two different types of atom. For example, I can talk about a molecule of hydrogen. A molecule of hydrogen, written as H2. A molecule of hydrogen is made of two hydrogen atoms. A molecule of hydrogen is made of two hydrogen atoms. We can also give an example using a molecule of water. A molecule of water written as H2O. So a molecule of water is made up of two different atoms. This one is made of two different atoms. That is hydrogen and oxygen, chemically bonded together using covalent bond. So that is what an atom is and what a molecule is. Next, we talk about the structure of an atom. So we can talk about structure of an atom. An atom is made up of three things. Number 1, an atom has got a nucleus. An atom has got what we call the energy shells, or what we call energy levels, and an atom has got what we call subatomic particles. Those are the three parts of an atom: nucleus, the energy shells, and also in them we find what we call subatomic particles. So in an atom, we will have a nucleus. The nucleus is surrounded by what we call the energy shells or the energy levels, where the electrons are orbiting. So this forms the nucleus, and these ones are the energy shells or the energy levels. Inside the nucleus, we find protons and neutrons. And in the energy shells, we have got electrons which are orbiting. Orbiting means they are moving. So an atom is made of a nucleus and energy shells or energy levels. In the nucleus, inside the nucleus, we find protons and the neutrons. And in the energy shells, we find what we call electrons. So protons, neutrons, and electrons are what we call subatomic particles. They're the smallest particles that are found inside an atom. So after knowing the structure of an atom, we want to talk about these subatomic particles and their properties. We have said that the subatomic particles are three. We have got protons, neutrons, and electrons. Let's first look on protons. Protons are found in the nucleus. They are found in the nucleus of an atom. They are found in the nucleus of an atom. They are positively charged. They are positively charged with a charge of +1, and they have a mass. They have a mass of 1. The relative mass is 1. So those are the properties of protons. Second, we talk about neutrons. Just like protons, neutrons are also found in the nucleus. Neutrons are found in the nucleus. They have no charge, which means they are neutral. They are not positive, they are not negatively charged. So they have no charge, but they have a mass of 1. So the relative mass of protons and neutrons is the same. The protons have got a mass of 1, neutrons also have got a mass of 1. Lastly, we talk about electrons. Electrons are found in the energy shells. Electrons are found in the energy shells of an atom. They have, or they are negatively charged. They have a charge of -1. Electrons have got a charge of -1, and they have a mass of 1/1836. You can round off to 1/1840, which means electrons are the smallest subatomic particles in an atom. These ones have got a mass of 1, these have a mass of 1, these have a mass of 1/1836, almost 0.00 something. Electrons are the smallest in an atom. So electrons are negatively charged, but protons are positively charged. Neutrons do not have a charge. They are not positively charged, they are not negatively charged. Now, we can make a summary of that to check the subatomic particles in an easier way. So we can have the particle, we can have the relative mass, we can have the relative charge. So 1 is the protons, the relative mass of a proton is 1, the relative charge is +1. Neutrons, relative mass is 1, the relative charge is 0. They don't have a charge. And then electrons, the relative mass 1/1836 or 1/1840, and the relative charge is -1. Protons are found in the nucleus. Neutrons are also found in the nucleus, but electrons are found in the energy shells. So I hope that is clear. So that is all about the subatomic particles, the protons, neutrons, and electrons. After that, we want to talk about atomic number and mass number. Atomic number and mass number. So first of all, what is atomic number? In the simplest way, atomic number, we say this is the number of protons in the nucleus of an atom. Atomic number refers to the number of protons in the nucleus of an atom. So atomic number is equals to number of protons. Atomic number is not protons. Atomic number is the number of protons. So atomic number is the number of protons in the nucleus of an atom. Next, mass number. Mass number, we say this is the sum of protons and neutrons in the nucleus of an atom. When we say sum, we mean you take the protons and you add to the neutrons. Those that are found in the nucleus of an atom, you add them together. When you add them together, what you get is known as mass number. Mass number in chemistry is also referred to as the nucleon number. We also call it nucleon number. Nucleon number because it counts what is inside the nucleus. So, mass number is equals to protons plus neutrons. It is the sum of protons and neutrons. That is what we call the mass number. Then, we have what we call atomic representation, the way we can represent an atom. So, atomic representation. How do we represent an atom? Like in the periodic table. I'll give an example with an atom known as cobalt. So, I will write CO, I'll write 59, and then I'll write 27. CO here is the symbol of the element cobalt. In this case, it is the symbol of cobalt. The upper number or the bigger number refers to the mass number. The lower number or the smaller number, whichever way it appears, the smaller number refers to the atomic number. But in the periodic table, in the Dexel book, this is the way it appears. So the bigger number refers to the mass number, the smaller number refers to the atomic number. We already know that the mass number refers to the sum of the protons and the neutrons, while the atomic number is the number of protons. So in this case of cobalt, we can say that the number of protons are 27. The number of protons are 27. The number of neutrons will be 32. Why? Because the mass number is equals to protons plus neutrons. And the mass number in case here is 59. Protons are 27, so plus neutrons. So to find the neutrons, you take 59, you minus 27, you get the 32. And then the number of electrons is equals to 27. Why 27? The number of protons is equals to number of electrons. The number of protons is equal to the number of electrons. So if the protons are 27, definitely the electrons will also be 27. That is what we call atomic representation. I can give another example, let's say with an atom of copper or an atom of carbon, for example. The symbol of carbon is C. The mass of carbon is 12 and the atomic number is 6. So C is the symbol. 12 is the mass number, 6 is the atomic number. So in this case, the number of protons are 6. The number of neutrons will also be 6, and the number of electrons will also be 6. 6 why? Protons are 6 because the atomic number is 6. Atomic number is the number of protons. Electrons are 6 because the number of protons is equivalent to the number of electrons. And the mass number is 12. 12 protons plus neutrons. Protons are already 6. So 6 plus another 6 will give us 12. That is what we call atomic representation. Another thing that we've checked about there that you need to understand is that the number of protons is equals to number of electrons. We had said earlier that protons are positively charged and electrons are negatively charged. So we say in an atom, if the number of protons is equivalent to the number of electrons, therefore an atom of an element is electrically neutral. An atom of an element is not positively charged, it is not negatively charged. Why? Because the number of protons is equivalent to the number of electrons. We say the positiveness of the protons cancels the negativeness of what? Of the electrons. If in case we have got protons which are 12, so the atomic number is 12 and they are positive, and we have electrons which are also 12 and they are negative, plus 12 minus 12 is 0. An atom of an element will not have an electrical charge. It will not be positive, it will not be negative, because the number of protons and the number of electrons is the same. That makes an atom of an element to be electrically neutral. So that is what you say when you are asked that in exam, that the number of protons and the number of electrons is the same. Finally, we talk about what we call relative atomic mass, abbreviated as RAM. So what is relative atomic mass? How do we get the masses of these elements? To get a mass, we need a balance to weigh them. So we have a balance, what they used, and in the balance, they have to weigh. How did they find out that magnesium has a mass of 24? They have to weigh it in a balance to know the mass of magnesium. So in this balance, we call it the carbon-12 scale. We use atoms of carbon, where carbon has got exactly 12 units. And then we use it to compare to the other one. So in this case, we can put an atom of magnesium, we put an atom of carbon. And the atom of carbon has got 12 units. We find that they don't balance because magnesium is still heavy. Then we put another carbon. If you put two carbons, you find that magnesium and the two carbons are balancing together. The two carbon, each of them has got 12 units. Two of them will be 12 times 2. That gives you 24. And that is how we find the mass of what? The mass of magnesium. If we put carbon with something like hydrogen, we find that they don't balance. Why? Because carbon, you find, is heavier than hydrogen. You can add another hydrogen until they will balance. You'll find that you are adding how many hydrogen? 12 of them, meaning that each hydrogen has got a mass of 1 for it to balance with carbon-12. So, but the first thing that you should know is how to define the relative atomic mass. So, relative atomic mass, we say that this is the weighted average mass of the isotopes of an element compared to the mass of carbon-12. It is measured in carbon-12 scale, where carbon has a mass of 12 units, or where carbon has got a mass of 12. We call it carbon-12 scale. It is abbreviated as AR. A with the subscript R. That is the abbreviation of the relative atomic mass. And relative atomic mass has no units. It is a ratio, so it has got no units. That brings us to something before we calculate the relative atomic masses. We have said that the relative atomic mass is the weighted average mass of the isotopes of an element. So we have to define the word isotopes for us to understand better what relative atomic mass is. So in this case, what are isotopes? Isotopes, we say these are atoms. That is the first thing that you must say. Isotopes are atoms. So we say these are atoms of the same element with different masses. They are atoms of the same element with different masses. They are from the same element, but their masses are not the same. In this case, what do we mean? I mean that they have same atomic number, but different mass numbers. Or we can say they have same number of protons, but different numbers of neutrons. So isotopes are atoms of the same element. So we can simplify this by giving an example. Let's say I give examples with carbon. So carbon exists in 3 different what? Isotopes. I can have carbon-12, carbon-13, and carbon-14. All of them are atoms of the same element. The element in this case is carbon. All of them are carbon. But this one has got a mass of 12, this one has got a mass of 13, this one has got a mass of 14. So they are atoms of the same element, but they are having different masses. Therefore, we say these three are isotopes of carbon. I can simplify this in a table where I can have the isotope. In having the isotopes, I can have the mass number, I can have the number of protons, I can have the number of neutrons, and then I can have the number of electrons. This helps you to understand it better. So the isotopes in this case is carbon 12, carbon 13, and carbon 14. Those are the three isotopes that we have. The mass number of this one is 12. That is why we call it carbon 12. The mass number of this one is 13, and the mass number of this one is 14. The number of protons. Carbon is number 6. Carbon is atomic number 6. Therefore, carbon, the protons will be 6. And the protons must be the same because they are of the same element. So, if the proton is 6 in this one also must be 6, this one must also be 6. We had said earlier that the number of protons is equivalent to the number of electrons. Therefore, if protons are 6, electrons are also 6, electrons are also 6, and here electrons are also 6. The number of protons is the same as the number of electrons. The difference comes in the number of neutrons. So here, because this one is 12, what is mass number? Mass number is protons added to neutrons. So 6 plus what will give us 12, therefore this one is 6. Here will be 7, 6 plus 7 gives you 13, and then here is 8. 8 plus 6 gives you 14. So carbon 12, carbon 13, and carbon 14 are isotopes of carbon. They have the same atomic number or the same number of protons, but they have got different mass number. Or we can say they have the same number of protons, but they are having different number of neutrons. They have got different number of neutrons. That is all about isotopes. So we go back and finally finish the topic by checking how to calculate the relative atomic mass. We can give an example. So we can be given, for example, a sample of chlorine atoms. You are given so many chlorine atoms, but in those chlorine atoms we are having isotopes. So we can say in them we are having chlorine 35 and we are also having chlorine 37. The atomic number of chlorine is 17, but chlorines may be having different number of neutrons. So we can come up with chlorine 35 and we can also come up with chlorine 37. So let's say we are given that chlorine 35 in the sample are 75% and chlorine 37 in the sample is 25%. Out of this sample that you are given, you are told to calculate the relative atomic mass of chlorine. If you want to get the relative atomic mass of chlorine, first of all, get the total mass. Divide by the total number of atoms. Divide by the total number of atoms. If I'm to get the total mass, 75% I've got a mass of 35 and 25% I've got a mass of 37. So to get the total mass, I must get the total mass of this one. That will be 35 times 75 plus the total mass of this one, which will be 37 times 25 of them. Then the total number of atoms will be the percentage here, which is 75%, plus the percentage here, which is 25%. The total will be 100. If you divide carefully, you'll find that the relative atomic mass of chlorine is 35.5. So first of all, get the total mass. Then secondly, get the total number of what? Get the total number of atoms and divide. So 35, those ones with a mass of 35, multiply by their mass, by their total number, which is 75%. Add to the other one, 37, multiply by the total number, which is 25%. Then divide by the total number of atoms, which is 75 plus 25, giving you 100. If you divide, you get 35.5. So you find 35.5 to be the relative atomic mass of chlorine. We have said that the relative atomic mass do not have units. So you put it just that way without without any units. So the relative atomic mass is calculated by giving out the percentage. You can be given another example. Let's talk about maybe example 2. I can be given a sample containing carbon atoms. So let's say, for example, you are given carbon 12, carbon 13, and maybe carbon 14. So you are told carbon 12 maybe is 60%. This one maybe is, let's say 30%, and this one maybe is 10%, for us to get 100%. Then you are told now, using this sample, calculate the relative atomic mass of carbon. This is just an example. What you need to do is to take the 60%, multiply by those with a mass of 12. So it will be 12 times 60, plus those ones with a mass of 13, multiplied by their total number, which is 30%, plus those ones with a mass of 14, multiplied by their total mass, which is 10. Then divide by the total number of atoms. That's 60 plus 30 plus 10, that gives you 100%. When you divide that, you will get the relative atomic mass of what? The relative atomic mass of the sample of the carbon atoms. So that one brings us to the end of the topic, and I hope that you have gained something.